Assalamualaikum warahmatullahi wabarakatuh. I am Siti Shuhada binti AZENAN. So today I want to present to all of you regarding the FYP1 presentation of mine, which is the topic is effect of corrosive environment on mechanical properties of aluminium bar wrapped with different types of fiber composites. So first, I will start with the project summary, which is this study will examine the durability and effect of corrosive environment exposure on different fiber reinforced polymer, which made of polyurethane resins. The flexural characteristic of aluminium bar, which wrap with different fiber, will be examined after the exposure to the numerous typical aging like accelerated weather and also soaking conditions. And then the result from the environment exposure will be compared with the control specimens, which is the control specimen will not be exposed to any environment conditions. Next, as an introduction, there are 4 types of fiber that we use, which is glass, carbon, basalt, and arenga pinnata, which is it will be reinforced by polymer, which is polyurethane resins. In industrial, pipelines suffer large losses and low structural integrity due to the both corrosion and also abrasion. That is why the research is carried out to investigate the effect of aluminium wrapped with different fibers under the different corrosive environments. And the constraints that we may be faced during undergoes this project is the availability of aluminium metal that caused by aluminium, which is because it will be mainly used in industry. And the exposure to environment conditions that we use based on the project is accelerated weather, soaking in neutral, which is distilled water, acidic, which is hydrochloric acid, and also an alkaline, which is we use sodium hydroxide. Next, I will move to the problem statement. As we all know that the corrosion of metal may affect the product structure, which is it can reduce the strength of the product. For example, the exposure of the aluminium metal to the high temperature and different soaking solution like neutral, acid, and alkaline will increase the tendency of the aluminium to corrode. Based on the existing study, the usage of the wrapping aluminium with fiber reinforced polymer approach may strengthen the metal. Hence, this project is focusing on the study of mechanical and physical properties of aluminium, which is before and after being wrapped with different types of fiber to see the result of the rate of the corrosions of the aluminium bar. There are 2 objectives that we want to achieve regarding our project, which is to determine the rate of corrosion of an aluminium bar and then to evaluate the mechanical properties FRP composites patching on the aluminium bar under the flexural loading after subjected to different conditioning exposure like accelerated weather and also soaking condition for neutral, acid, and alkaline solutions. Next, for the scope and limitation, this is the design of the experiment, which is we include the control specimen and also some of the conditioning exposure like accelerated weather, soaking, and also anti-fouling. For the control specimen, we will undergo the density and also rate of corrosion test. And the samples need to have no crack or any conditioning exposure. And it only includes no wrap sample, which is we required 3 samples for this control specimen. And then next, for the conditioning exposure, we will left in chamber for 21 days for the accelerated weather, which is it needs 3 samples each for no wrap and also for the other fibers like glass, carbon, basalt, and also arenga pinnata. And for soaking, we will monitor on day 30, 60, 90, and also 120, which is it's about 4 months. And it includes neutral, acidic, alkaline, which is it's only required 12 samples for each, which is no wrap and also the other 4 fibers. And last one is anti-fouling, which is we need to soak the samples under the seawater, and the total of the total of the samples required, it's just same like the soaking. Based on the literature review, this is from some of the articles that I take, which is first for the rehabilitation of corroded metal pipes using FRP. Based on the George et al., it is found that the FRP composite is better for strengthening rather than repairing when wrapping corroded sections with FRP. And then next, steel or other metallic materials are typically used in damaged pipes. They are repaired using FRP composites because of their dependability, safety, and also ability to contain pressures. Next, for the effect of conditioning on the FRP composites, based on the literature review, it is found that the sisal fiber treated with a 0.5% NaOH solution will increase the compressive strength and decrease the water absorption of sisal or epoxy composites. And the 5% NaOH solution was used to alter flex fabrics, which is based on this article, they discovered that the treatment eliminated the oil and wax contaminants from the flex fiber surfaces, and as a result, the flex or epoxy composites mechanical properties such as tensile and also flexural capabilities will be improved. There are some of the methodology regarding the project, which is the sample preparation. We use vacuum bagging, which is the resins used is polyurethane conduit 250 OMPL summer heats. And then for the air-stressed weather, the sample is exposed to the extreme temperature in the chamber to evaluate the physical condition of the sample. And like I've said before, it will left in chamber for 21 days. Next, for the soaking, it will soak in acid, which is hydrochloric acid solution, alkaline, which is sodium hydroxide solution, and also neutral, which is distilled water. And these samples will be monitored on the 30, 60, 90, and 120. For the flexure test, the sample being tested using the Universal Testing Machine or UTM. And the parameters of this machine is support span of 48 mm and 3-point bending is used to identify the strength and stiffness by amount of deflection on the mild steel bar or aluminium bar. For the rate of corrosion test, it will be identify the electrochemical behavior of material using potential dynamic test, which is based on this potential dynamic test, the TOEFL plot will be obtained, which is to determine the rate of corrosion of material. For the expected result, this result came out from the literature review, which is the first one is flexural properties of BFRP or basalt fiber reinforced polymer after being immersed in acid and alkali. Based on the figure 2, HCl or hydrochloric acid specimens maintains high level of their flexural properties, and based on the figure 3, the specimen in strong alkali are corroded more severely, which is NH3H2O or ammonia water. Same goes with NaOH, natrium hydroxide. And the next one is the effect of specimen thickness on flexural strength of CFRP laminates in distilled water and alkaline solutions, which is distilled water is neutral solutions. So, based on these figures, the flexural analysis in figure 4 to 5 display the relation between the various aging durations to the thickness of specimen and flexural strength retention. The bulkier specimen retain more strength. This is based on the thickness. And the last one is tensile strength against exposure time for GFRP under various conditions. GFRP is glass fiber reinforced polymer. So based on this figure, GFRP demonstrated the best resistance to weak acidic environments, which is it maintaining 49.4% tensile properties after 500 days in a 5% hydrochloric acid environment at 22.3 degrees Celsius. And for the tensile properties were predicted also to decrease by almost 40% after only 89 days in a 5% sodium hydroxide environment at 22.3 degrees Celsius. So based on this one figure, it includes for the neutral, for the acidic environment, and also for the alkali environment. That's all for me. Thank you.